Okay, so we have our last topic, which are the four laws of their thermodynamics. Of course, we have first, second, third, and the zeroth law. So the first law, a very popular one, which is the conservation of energy. So conservation energy only states that Q in is equal to Q loss, right? Or no energy, energy can never be created nor destroyed. It can only be transferred. Okay. So for the second law, we have energy has quality and quantity. So this indicates on how to use the energy and how much you can use of an energy. Okay, so not all of the energy supplied can be converted to useful work. There will always be losses. That's why we can only have a theoretical, the 100% efficiency only exists theoretically because there will always be losses. So used to test the efficiency of an engine, of course. So the third law, pure crystalline substance at 0 Kelvin will have its change in entropy approximately 0. So this is also simple. So the third law also just simply indicates that at absolute temperature or at absolute zero temperature, that is a 0 Kelvin or negative 273 Celsius, all activities stops. Okay, so there is no activity during that temperature. Okay, so therefore there will be no change in entropy. Therefore, it will become approximately zero. For the zeroth law, this is also simple. If a third body come in contact with two bodies in thermal equilibrium, all of them will be in thermal equilibrium. For example, there are two bodies that is already in thermal equilibrium. If another body touches them, then those three bodies will be in thermal equilibrium. Simple as that. Okay. So we have now let's move on to the heat engine. Okay. So for the heat engine, okay, heat engine, we have the Carnot engine cycle, most ideal and efficient engine. So we have two isothermal and two isentropic processes here. For the Otto engine, we have gasoline. This is the gasoline engine, and it involves a spark ignition engine. So this is two isometric and two isentropic process. For the third one, we have the diesel engine. This is also the compression ignition engine and doesn't involve any spark plugs. So we have here one isometric, one isobaric, and two isentropic processes. Now, as you can see or as you notice that every engine has exactly four processes each. Okay, so for the formulas here, so the Q and T ratio and proportion them. So you'll have something like this formula: QA over TH is equal to QR over TL. TH and TL stands for T high and T low, or the temperature high and temperature low. For the energy balance, we have QA is equal to W plus QR. Now, become if you transpose some of the givens, you'll just have W equal to QA minus QR. Okay. For the efficiency, that is just W over QA times 100, of course, to make it in percentage, or QA minus QR all over QA, or TH minus TL all over TH. We have when you're dealing with refrigerators and air cons. So we have here some formulas. Again, ratio and proportion of Q and T. We have here a little bit different from the last one. We have QA over TL equal to QR over TH. So for the energy balance here, you have here QA plus W equal to QR. And if you transpose some of the quantities or parameters, you have here W equal to QR minus QA. We have here the coefficient of performance or COP. So remember that COP must always be greater than 1. It can never be equal to 1. It must be greater than 1. COP is also equal to QA over W or QA over QR minus QA or TL minus all over TH minus TL. Okay, so we have the last one, which is the energy efficiency ratio or EER. It is the amount of heat removed in BTU per hour or kilojoules per hour per watt of power supplied. So that is the EER. So the formula for EER is very simple. We have EER is equal to COP times 3.42, and that's it. So with that, let's solve some problems.